And now we'll look at number 18 from the fall ACP review. It says, what is the domain of this function? Now, we've learned a few ways of doing this. One is by graphing, but I'm going to first use just the algebra rules because it's the most consistent. What you do when you have a rational, that means like a fraction, is first we try to factor and see if we can cancel anything. I see that there is a GCF here of x. They both share an x. So if I pull out an x there, it's like reverse distribution. I'm left with x plus 3. When you do this, we can see that these x's cancel, and that means we have a whole or removable discontinuity at that spot. Now, since x is by itself, it would be at x equals 0 that we have that whole or removable discontinuity. I forgot to put whole there. And then here, this is an infinite discontinuity. Which means it's an asymptote when x equals -3. So if we had to write the domain, we would write domain from the left, because this would be all reals except for these two values. So we'd go from -infinity all the way, this value comes first, to -3. And since it's an asymptote, it'll be a parenthesis. And then we pick back up on the other side of -3, and we'll go all the way to 0. And since it's a whole, again, we're not equal to that value. And then from 0 to positive infinity. This should be my answer right here. And then we could also graph it in the calculator just to make sure. So if I go over to graph, and I would type in the equation here, and I get a fraction, x over, I'll type in the original, x squared plus 3x. And there's the asymptote at -3 I was referring to. Now there needs to be a whole right here. The way to check is if you press Control T, at 0, are we undefined? We are. It says undefined both at -3 and at 0. So we're in good shape there. That is in fact a whole right there.